All right, starting out with this review, Elijah, what is A sub n? Hmm? Emma, A sub n. Josh, A sub n. It's the name of our sequence. And you better be writing this down. Ethan, what is A sub 1?
Initial condition, starting term.
It's your initial condition or starting term. Haley was not here. Elijah, what is N? Emma, what is N? Do what? Okay, thank you for being honest. Elijah.
I don't have it written.
Okay. Josh.
Number of place term.
Yep. It's a number or place. It's kind of like it's a number or place of the term in the list. A sub n minus 1, Ethan?
I didn't do
Did you get that one, Josh?
consecutive term to a sub n.
It's a consecutive term to A sub n. We're going to start out with the definition. So in arithmetic sequence, is a sequence where, and if you can't read cursive, listen to my words. An arithmetic sequence is a sequence where the difference between consecutive terms is constant. So a sequence where the difference between consecutive terms is constant. So what does that even mean? What was our name for a sequence? Emma? Elijah?
A sub n.
A sub n. So we'll have A sub n. I'm going to put this a little higher. A sub n. That is my sequence. And it is the difference between that and a consecutive term. So what is my consecutive term? Haley?
A sub n minus 1.
A sub n minus 1. So I have difference of consecutive term is just going to be equals constant. And we are going to be calling our constant term D. Looking at this formula, we had two different formulas that we talked about yesterday. What two were they? What were the names of them?
Recursive, explicit.
Recursive and explicit. Very good. So looking at this, is this recursive or explicit?
Be recursive.
Be recursive? That's correct. Why?
Because it has to, the numbers rely on the first one.
Yeah, right, because of the consecutive terms, or you can just say it has the a sub n minus 1. As long as it has a sub n minus 1, it's going to be recursive. Okay. So this form is recursive. So we also have an explicit formula form. So our sequence, which is still a sub n, is going to be equal to a sub 1. What is a sub 1, Emma? I cannot hear you. Initial condition, thank you. Plus n, what is n, Ethan? Yeah. Minus 1 times d. What is d, Elijah? It's our constant. Very good. So this guy is going to be our explicit formula. So let's do an example. Our example is going to say, is the following an arithmetic sequence? Is the following an arithmetic sequence? And we'll have two different examples. So we'll start out with this one on the left where we have 3, 6, 9, 12, and 15. So Ethan, can you give me an example of two consecutive terms? Josh, can you give me an example of two consecutive terms? 12 and 9? Because they're right next to each other? Give me an example of two consecutive terms, Elijah. 3 and 6? Because they're right next to each other? Okay, so let's use Elijah's example of 3 and 6. What is the difference between 3 and 6? 3? What's going on? Are we adding 3, subtracting 3, multiplying? So I want you to say plus 3. Let's look at the next two. Well, Ethan, why don't you give me an example of consecutive terms? 12 and 15. So what's the difference between 12 and 15? What are we doing with 3? What operation? So say adding 3. All right, Emma, give me two consecutive terms. 6 and 9, and what's the difference between them? You're adding 3. Thank you. Haley, give me the last one.
9 and 12.
Okay, and the difference between them?
3 plus 3.
Yep, adding 3. So the question is the following an arithmetic sequence? I've got 3, 6, 9, 12, and 15, and I'm adding 3 each time. What was the definition of our arithmetic sequence? Anyone? Very good. So we're looking for the difference between consecutive terms being constant. Is this constant? Yes. So in this instance, we would say, all right, my D is equal to 3. And so yes, it is an arithmetic sequence. So let's do this one. 1, 4, 9, 16, 25. Caden, give me an example of two consecutive terms. Haley, give me an example of two consecutive terms.
1 and 4.
1 and 4. What's the difference between them?
30 plus 3.
You're adding 3. Give me two consecutive terms, Josh. 4 and 9. What's the difference between them? What are you doing with 5? Adding 5. Emma, consecutive terms. 9 and 16. Okay, what's the difference between them? Adding 7. Thank you. Elijah? 16 and 25. What's the difference? Plus 9. Is this constant? Is this the same? Yep, so we don't have a D, so that means what? It is not an arithmetic sequence. Very good. You're going to be asked questions like this. It'll say, what is the 100th term in the sequence? That sequence is going to begin 6, 11, and so on. So what is the 100th term in the sequence? So let's start out with what we do know. What is my initial condition? 6. How do I denote my initial condition? What did I write that as at the beginning of class? Yeah, A sub 1. Very good. Perfect. So we do know my initial condition. That's the first term. So let's see if we can find the common difference. What's the difference between 6 and 11? You're adding 5. So what variable represents 5? D. So that's going to be our common difference. So you are going to use this formula whenever you have any questions like this. You are going to use the formula A sub n is equal to A sub 1 plus n minus 1 times D. This is very, very important. Put little stars around this thing. You're going to use this a lot. And as long as you have your formula, these problems shouldn't be too bad. So what you're doing is you're trying to find the 100th term, okay? So I'm going to put A sub 100 because that's what I'm trying to find. I don't know what it is, so I'm going to write it like that. Then I have A sub 1. What is my A sub 1? Anyone? 6. Then I have plus. Then I have n minus 1. What do you think my n is? 11? So I'll give you a hint. A sub n, we made that A sub 100. So it's going to be 100. Minus 1 times D, which D was what? 5. We know how to solve this. 6 plus 100 minus 1 times 5. Which operation do we do first? 6, 100 minus 1, or times it by 5? Yeah, 100 minus 1. Why is that? It's in the parentheses. So you're going to have equals 6 plus 99 times 5. What am I going to do next? Multiply. So 495, I think. And then 6 plus 495 should be 501. Cool. I've got 501 now. What the heck does that mean? I just got a number. So the 100th term, A sub 100, is 501. You can also follow this A sub 100 all the way down. A sub 100 is equal to all those things. So I want you to do one. I want you to do the example. What is the 40th term in the sequence? What is the 40th term in the sequence? And let's say that it says 3, 7, 11, so forth. So try and find the 40th term on your own. I didn't explain this one. So we added 4 each time. We decided that we were looking for a sub 40. We had 3 for our initial condition. 40 was in, and D was equal to 4. And then we just solved. So our next example is going to be, what is the second term? What is the second term in the sequence? And you're given the sequence 21 blank 63. Well, last time we found this by going, okay, the difference between these guys was whatever our D was, right? And the difference of these guys was whatever our D was. So if we think about it, we think this 21, if we add D to it and we add D to it again, that's going to be 63, right? So 21 plus D is going to give us 63. We can solve that, right? What do you want to do first, Emma? What do you want to do first? What do you think, Elijah? Put together the two Ds. Okay, so we'll have 21 what? So this is the thing. What's D plus D? It's 2D. D squared is D times D. Is equal to 63. What do you want to do next, Haley? So you have 2D is equal to what? 42. And then lastly, we'll divide by 2. So we get D is equal to 21. How is that helpful? Yeah, so if I look back at my little diagram here, where I was adding D each time, well, now I'm adding 21. And so it's going to be 42. I'm going to let you guys do an example, and it's going to be a little bit different. And it's going to ask you about the second and third terms of the arithmetic sequence. So for example, what are the second and third terms? What are the second and third terms? And you are given the sequence 100 blank blank. I almost said the answers out loud. So stupid. 82 ... I'm going to give you some time on your own to think about it. But I want you to think about, you don't have to write this down again, but think about how we had 21 blank 63 and we added D each time. I want you to think about that. So he said 100 plus D, but then he said plus D again is equal to 82. He did that because if we look at that little diagram to the right, we added D, but this time we added it 3 times. So what did you do to solve, Elijah? So 100 plus 3D is equal to 82. And then what did you do? Okay, so minus 100 is going to equal 3D is equal to what? Negative 18. And then what did you do to solve? Very good. And so what did you get D to be equal to? Negative 6. So what does that mean? Yeah, so you subtract 6 from each spot. So you're going to have 100. You're going to have 100 minus 6. Will be what? 94. 94 minus 6, which will be what? Very good. And this makes sense, right? Because 88 minus 6 is 82. See that? So something Elijah pointed out was that these numbers were actually going down, and a lot of you guys noticed that. So some of you tried to do like a negative D or something like that, which is totally understandable, right? The only thing is whenever we did this math on our own, it showed us that in the problem. It ended up being a negative anyway. Whenever you work out the algebra, it'll represent itself. So let's do this. This is the last guy. So the 9th and 11th terms in a sequence are 132 and 98. What is the 10th term? So the 9th and 11th terms in a sequence are 132 and 98. What is the 10th term? So I can say, all right, my 9th term is 132. I don't know what my 10th term is. And the 11th term is 98. So this is the 9th one. This is the 11th one. This is my 10th one. How do you think we can find this? We can do it in the way that we just last solved, right? Or something that we can do is you can use the arithmetic mean. The arithmetic mean says that there's 1, 2, 3 numbers. And I'm trying to find the middle one. So I can take 132. I can add 198. And if I divide that by 2, that will be my answer. So 132 plus 98 is going to be 230. Is that right? Yeah. Divided by 2 is going to be 115. So on the example before where we had 21 blank 63, do you think it'll work then too? Let's find out. Let's look at 21 plus 63 and let's divide that by 2. What's 21 plus 63? 84 divided by 2 is what? Isn't that the answer we got? Ta-da! So you didn't even have to find the constant difference for those. But that only works whenever you're just looking for like one of those slots, okay? It doesn't work if you're looking for the second and third term and stuff like that. That's not gonna work. Yeah, let me get back to this. I would like to have you guys refresh on one of our examples from yesterday. So I want you to solve this problem. I want you to find the first 5 terms in the sequence given a sub 1 is equal to 2. And you have the sequence a sub n is equal to 3, a sub n minus 1, plus 5. I'll give you a hint. If you remember yesterday, we made our little chart in an a sub n. All right, Emma, can you tell me what's going to be in this left-hand column? What are we going to write here? We're going to write 1, okay. What else? What do you think, Haley?
You're gonna write 1 through 5.
Why are we writing 1 through 5?
Because we have to find the first 5 terms.
Correct, first 5 terms. Okay. I also have this a sub 1 is equal to 2. I can put that somewhere. Where is that, Josh?
Right under a sub n.
Yeah.
Right next to 1.
So whenever I look at this equation and I have a sub n is equal to 3 times a sub n minus 1 plus 5, the way that you start out is you go, okay, I already have 1, so I don't need to start out at 1. What I need to find starts at 2. So I'm going to try and find 2, because whatever's on this side, you're trying to find it. I don't know what that is equal to 3 times a sub 2 minus 1 plus 5. Because if I substitute this in with that in, I think I substitute this in with that one. So what do I have, Josh?
3a sub 1 plus 5.
Very good. 3a sub 1 plus 5. Well, we know what a sub 1 is, right? What is that?
2.
So we have 3 times 2 plus 5. And we know how to solve those. That's just 6 plus 5 or 11. So you put 11 right here. Another hint is because we're using consecutive terms, if this process confuses you with the minus 1s and all of those things, you can just think, if I'm trying to find a sub 3, that means my equation is going to use a sub 2. If I am trying to find a sub 4, that means my equation is going to use a sub 3. If I'm trying to find a sub 5, that means my equation is going to use a sub 4. Do you see how that works, that pattern? That's why we call them consecutive terms. And that's why it's recursive, because we're using the same information over and over again. So Ethan, what is a sub 3? 38. So So we'll have 3 times 11 plus 5, 38. Elijah, what's a sub 4? You can walk me through it. We've got 3 times what?
3 times. Three times a, so it's 4 minus 1.
Mm-hmm. And so what's 4 minus 1?
3.
3. So we have, let me make sure I've got this over here. So we have 3 times a sub 3 plus 5.
So it's 38.
Yeah, so 3 times 38 plus 5 is going to equal what? You can toss that in the calculator. I will not begrudge you for that.
190.
190. Is that what everyone else got? 119. All right, Kaden, walk me through the last one. I've got 3 times a sub 4 plus 5.
Equals 3 times 119.
Mm-hmm.
Plus 5.
Mm-hmm. And so what is that?
$363.
362. Is that what everyone else got? So those are the first 5 terms in the sequence. All right, you may use your notes. You can use your notes. You can use a calculator. I'm pretty sure you don't need to use a calculator, actually. I don't know why I printed with an extra page. Thank you. You're welcome. One thing to note, on the very bottom of that page, number 5, it needs to say where a sub 1 is equal to 3. Sorry. Number 5 on the first page, it's supposed to say where a sub 1 is equal to 3. I always miss something.